Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will continue with the developing UV protective textiles. In last session we have discussed various factors on which the UV protection depends, and here onwards we will discuss the research study which has been carried out in house to understand the fabric engineering, to actually the effect of different parameters and how to engineer fabric to achieve required UV protection. So, let us try to understand once again the effect UV radiation. It causes the skin cancer. So, as we have discussed, the UV radiation may be directly from solar radiation or artificial UV. This immune system, immune suppression, skin cancer it can create, or maybe in eye it affect the eye. So, that these are the different effects of UV. So, we can see the at the skin, the sunburn can take place, skin cancer, okay. So, skin erythema. So, different types of effects are there on skin. So, the preventive measures are basically behavior we can measure, as we have discussed, by environmental or legislation changes that we can do. So, we can create the UV index, personal protection we can use, this we have already discussed. And then the main thing is that can we develop a clothing which will prevent us from the UV protection. So, our basic idea in this research is that to create suitable clothing, to develop suitable clothing which will protect us from UV radiation, and to understand the structural characteristics, different fiber characteristics, what are the changes in the effect of the fabric structural characteristics on the UV protection performance, that we will try to understand here. The ultraviolet protection factor using the sun protective clothing. So, there are different factors which influence the UPF in a clothing. So, we know the fiber type, we know the fiber parameters like type of fiber, type of polymers which are used to produce this fiber affect the UPF. Yarn parameters, yarn twist, yarn porosity, yarn linear density, they affect the UPF value. Fabric parameters are there, typically the primary parameters, the weave, yarn count and thread density, these are the primary parameters in fabric, and which indirectly changes the secondary parameter like weave yarn count and thread density are the function of fabric cover factor. So, fabric cover factor can be changed by either changing the yarn count and thread density, fabric porosity can be changed, fabric aerial density can be changed by all these parameters, fabric thickness can be changed and yarn crimp that can be changed. So, these are the secondary parameters which affect the UPF value, but this secondary parameter can be controlled by weave yarn count and thread density. Then other factors dyeing and finishing parameters. So, we can, as we know, if we want to have more UPF value, so we can use the darker shade or we can use the ultraviolet protective finishes on the fabric. And last is the maintenance related parameter, how the washing will be there, what type of, whether there is any rubbing takes place and different type, whether there is any thread distortion is taking place during washing. So, this is the maintenance related parameters. So, all these parameters affect the UPF. So, in our present study what we will try to understand the fabric engineering. So, in this zone we will try to study to develop certain fabric which will result higher UPF. Now, the research gap was at that time was that, so contradictory opinion exists about the superior UV protective properties of bamboo viscose. So, whether bamboo viscose fiber has very high UV protective properties or not, the research shows the contradictory results as compared to the cotton fabric. In some research it has been observed that bamboo viscose has got fabrics made of bamboo viscose will have higher UPF than cotton. So, in the present research we tried to clarify. So, we tried to study in depth whether bamboo viscose really results higher UPF as compared to cotton or not, that we have to study. We studied in detail. Next study was that the effect of some selected yarn structural parameters like yarn twist, yarn structure, we have created hollow yarn structure. So, on UPF of woven fabrics. So, whether the yarn, if it is yarn is hollow, how is it affecting the UPF of woven fabric, keeping all other parameters constant. Another case, if we change the twist, whether twist actually affect the UPF value of woven fabric is or not, that we have to analyze. So, if we change the twist, the two contradictory thing happens. One is if we increase the twist, the space between the interfiber space changes, which increase the UPF value, but at the same time as the diameter reduces, the inter yarn space increases, that may reduce the UPF characteristics. Now, we have to, with the experimental data, we try to understand the effect of the yarn twist on the UPF value of woven fabric. The next study what we did, the fabric thickness and pore size. Pore size means pore between the yarn. So, inter yarn space, how the fabric thickness, keeping all other parameters constant, if we change the fabric thickness and the pore size of the fabric for same cover factor. So, we are trying to keep the cover factor same, like this is the say cover between. Now, let us draw it properly. These are the openings. So, there are 1, 2, 3, 4, 5, 6 boxes of larger size. Now, keeping the same cover factor, if we do like this, so same cover area we can break it with a large number of small openings, keeping the total volume, total area of covers same. So, that we have created, and we tried to understand the effect of the pore size, keeping the same fabric cover. How are this affecting? So, fabric thickness and pore size may have opposing influence on UPF. So, that we have tried to understand, and the resultant effect of these two factors need to be studied. So, fabric thickness if we reduce, then we can expect that the UPF will increase, UPF will reduce. So, that transmission will increase, and pore size if we reduce, that will expectedly the transmission of UV ray will be increased. So, once we understand this interaction, then we will come to know how the fabric thickness and pore size are affecting. So, that we have done a detailed systematic study on this, that we are going to discuss here. So, comparative analysis were done in vitro UV protection by fabric woven from cotton and bamboo viscose fiber. The first study we tried to understand whether bamboo viscose fiber has really higher UPF that or not as compared to cotton, that we tried to understand. Now, bamboo viscose, which is regenerated cellulose fiber from bamboo pulp, the main advantages which has been reported, it produces soft and cool feeling, it is non irritating, thermoregulating properties, because as it absorbs moisture. So, it is comfortable, high moisture absorbency, it is breathable, the moisture vapor can pass through the bamboo viscose fiber easily, and its inherent antimicrobial property that is reported, and it is reported that it has inherent UV protective property. So, that has been reported, and that we have to analyze whether this fabric made from the bamboo viscose has got higher UPF value or not. So, the contradictory opinions are available in the literature on UV protective properties of bamboo viscose as compared to cotton fabric. So, the reports are there. The commercial bamboo fiber has better UV absorbency property than 100% cotton, okay, that is reported by a researcher. So, worked on several 7 polyester bamboo blended knitted fabric, some in a report. So, in another study, so different polyester bamboo blended knitted fabrics, and they reported that UPF increases with increasing the percent of bamboo fiber. So, UPF increases, that they have reported. On the contrary, the report is, there is a report, the cotton fabric possesses higher UPF capacity, so UV protection capability than bamboo and viscose fabric. So, there are contradictory reports. Cotton generally in a natural condition with the natural wax or natural colors are there, that may absorb UV ray. So, these are the contradictory results. So, our idea was to reinvestigate these issues scientifically and try to see whether the bamboo viscose is really better as per the UV absorption capacity or not. So, we have designed our experiment. So, materials which we have used 3 different count of yarn, which are made of 100% cotton and 100% bamboo viscose fiber. So, 3 different yarn counts were taken. So, 18 fabrics were prepared, 9 fabrics are of cotton and 9 corresponding bamboo fabrics. They have identical parameters. So, we have created fabrics with identical parameters like yarn count and fabric set. So, on loom parameter we have created identical. So, fabric set, ends per inch and picks per inch we kept same, and yarn counts are exactly same. We have, so end density was kept 50 50. So, ends per inch we have kept 50 for all the fabrics, okay. And warp and weft yarn counts were kept same at the same level for any specific sample. So, warp and weft count yarns were kept for a particular sample. Now, here we can see we have produced plain woven fabric, end density was kept, 50 was the end density, 50 ends per inch. For cotton and bamboo viscose, for both the fibers we have created the yarn count 20, 25 and 30 yarn counts we have used for both cotton and bamboo, and picks per inch we have taken 50, 60 and 70. So, for cotton we created 9 fabrics with a 9 combination, 3 multiplied by 3, 9 combination, and for bamboo also such 9 combinations we have created. So, same fabric structure we have kept. Thread density was measured as per the ASTM standard, aerial density were measured, and cover factors. So, optically we have measured the percent cover by microscope, and shrinkage percent was calculated based on the percent yarn spacing before and after wet processing. So, that way we can measure the shrinkage, also we can measure the shrinkage, we measured the shrinkage based on the fabric dimension also. So, yarn spacing before and after wet processing, because here we wanted to know the spacing, pore size. UPF we have used ATCC method, ultraviolet protection factor of fabric. Now, try to see the result here. Now, this is the result which we have observed. Now, what does it show? So, with the for cotton fabric, as for 20 count yarn at 50 picks per inch, the UPF value is 7.82. With the same combination, the viscose fabric gives the UPF value 11.12. That means, with the normal understanding what we used to tell that okay, bamboo viscose fiber results higher UPF. So, that is true, it appears apparently it is true. So, we can say for keeping all the parameters at the loom state, peak density, okay, because ends per inch is kept same. So, with that structure we have got the higher UPF. So, 42% increase in UPF in case of bamboo than as compared to cotton. So, if you see the entire range of fabric, So, 9 combination, in all the combinations we have got very high percent of increase in case of bamboo fiber. So, typically around 30 to 50% higher UPF in case of bamboo, keeping all other parameters same. So, initially we thought okay, this is the result which is actually as per the normal published data, normal perception. So, this must be true. Then we thought okay, the cotton and viscose, they are basically the cellulosic structure, and cotton has got higher crystallinity. So, we had little bit doubt on this type of results. So, we tried to study in depth. Now, we tried to go in depth. So, we studied the cover factor, fabric cover factor, and what we have observed after the washing or something, we have seen the cover factor here. It is not calculated cover factor. This is the cover factor based on the spacing. Now, peak density, here cover factor for most of the cases, particularly for finer yarn, we have seen that cover factor for bamboo is more. So, for bamboo viscose, the cover factor is higher than the cotton in general for most of the cases, particularly it is the trend is very prominent in case of the finer yarn. And also interestingly, what we have observed, that aerial density. So, initially we have kept the yarn count and peak density, end density same, but what we have observed, the aerial density has changed. The viscose, bamboo viscose results higher aerial density as compared to the cotton for all the fabrics. Okay. So, then we tried to go further, we tried to understand the correlation, and tried to see the shrinkage value. Now, if we see the shrinkage, both warp wise and weft wise shrinkage, the bamboo viscose result very high shrinkage as compared to cotton. For all the fabrics, all the combinations, both warp way shrinkage and weft way direction, in both the directions the shrinkages are very high in case of bamboo viscose. That means, there is something to do with the pore structure changes. Then what we have tried to predict the model. So, predictive model we have tried to frame, the regression analysis we have done, and regression equation we have tried to frame based on the cover of cotton fabrics. So, cotton fabric cover we have measured, okay, and then we have measured the UPF value. So, at different levels, different combination of cotton fabric. So, we can see these are the for cotton fabric the fabric shrinkage, and we have calculated the cover factor. We can see the cotton, this is the UPF value. Let me go back. So, here UPF value we have seen, we have calculated the cover factor for all the 9 fabrics, and then we measured the UPF value. Now, you can see the regression equation which you have got. This is the regression equation. Y is the UPF value, y equal to 0.0158 e to the power exponential equation we have got 0.067 x, where x is the cover factor. So, if we change the cover factor, we get the changed UPF value. So, here you can see the coefficient of determination is given by r square. So, it is good 0.96, and mean absolute percent error MAPE, which is 7.41. So, that is the UPF prediction from cover factor in case of cotton. So, if we know the cover factor, we can predict the UPF value here. So, cover factor can be calculated from the structural parameter, or by the yarn spacing we can calculate cover factor, and accordingly for cotton we can predict the UPF value using this equation. Now, what we tried? We tried to use the same equation and predict the cover factors of UPF of viscose, bamboo viscose, using the cover factor of bamboo viscose. So, we want to predict the UPF for bamboo viscose using the cotton cover factors model. So, cotton cover factors model was, this was the model. So, this is the model for cotton cover factor, which we have predicted, and we tried to use the same model to predict the UPF of bamboo viscose. Now, here for bamboo viscose you can see here the cover factor is given here in this column, and UPF value is given in the second column, and using this cotton cover factor model we tried to predict the UPF. So, for sample 1, actual observed UPF is 11.12 for viscose fiber, viscose fabric, but if we predict using the cotton cover model, it is 8.88, it is predicting. So, actual error is 2.24 and absolute error percent is 20%. So, we can see the mean absolute percent error, it becomes very high. In case of cotton, predicting cotton fibers model using the cotton cover, the mean absolute percent error is 7.41, but if we want to use the same model to predict the UPF of viscose, bamboo viscose, the error has increased. So, it shows that this model is not the perfect model for that, for using to predicting the UPF of viscose. So, then what we have done, UPF of bamboo on its own cover. So, we tried to develop another model, regression model using its own cover factor. So, bamboo viscose cover factor is given here and UPF value is given, and UPF value is reported in this second column as it was given here in the earlier table. Now, we have developed a model here. So, this was the model, this is the model for the bamboo viscose cover. So, here it is a predictive UPF value of bamboo viscose using its own cover percent model, that means its own means it is its own fiber, that is a bamboo viscose cover factor, where mean absolute percent error is 14.54%, it is a less than cotton which was shown earlier 18. So, 18.15. Here it is a little bit improved, but still it is not that low, because regression R square is 0.87. The solid line shows the predictive UPF value of bamboo viscose using cotton model. Okay. So, we thought that cover factor is the good predictor of UPF, but in both the cases we found that the error is high. Then we thought that let us discuss go for the areal density. So, whether areal density has got, how is it impacting the UPF value. So, predictive model for UPF from areal density of cotton fabric, that we have tried to understand. So, this column, it is giving the areal density of cotton fabric at different combination and related corresponding UPF value, and we have got this equation y equal to 1.047 6 e to the power 0.0145 x. So, y is UPF value and x is the areal density. So, here if we know the areal density of cotton fabric, we can predict the UPF value, particularly for this type of fabric, and here we can get the MAP value. It is 7.24, that is lower than earlier, and we get the R square value 0.95. So, relatively better prediction. Again what we have tried? We have tried to use the same cotton model, cotton areal density model to predict the UPF of viscose, bamboo viscose. So, this is the cotton model. Now, we want to predict the UPF of bamboo viscose fiber. Now, here we see that the areal density of bamboo viscose fiber fabric and observed UPF, and using this model we predict this UPF here. So, for 177 grams per square meter, the observed by testing we observed 11.12, but using the cotton model, cotton areal density model, it is predicting 13.64. So, actual error is minus 2.54 and absolute error we got, it is a 22.66%. So, that for 177, for all other combinations we have calculated the different error, and mean error, the mean absolute percent error is 8.75. So, which is lower than the cover factor model. This error is lower than the cover factor model. Then the question is which one we should use, and can it be reduced further? To understand more, we further what we have done, we have used its bamboo viscose fiber fabric's own model, okay, on areal density. So, UPF of bamboo viscose fabric versus areal density, its own model we tried. So, these are the first column shows the areal density of bamboo viscose and corresponding UPF value that we have seen in the last slide, last table we have seen, and we tried to develop the relationship. So, regression equation which we have got here, this is the predicted UPF value of bamboo viscose using its own areal density model. Here you can see the error is least. So, if we predict through the areal density, in case of bamboo, it has error is mean percent error is that 4.93, very low, and the R square value is 0.97. So, its prediction is very low, very good prediction, because the error is very low, and as compared to that with the cotton model, the error was 8.75. So, this is predicted solid line the predicted UPF of bamboo viscose using cotton areal density model. So, this is the cotton areal density model, and here this one is the bamboo fibers own areal density model. So, if we try to see in a combined manner, now you can see here, if we consider the input parameters as cover factor, should we go for cover factor model? So, in cover factor model we see the error is higher than the areal density model for cotton, although it is low, but for bamboo viscose using the cotton model, it is much higher than its own model, and for the areal density model for both cotton and bamboo viscose within its own model, it gives the least error. So, the thing which we have concluded that we cannot interchange the model, we cannot use the cotton model to predict the bamboo viscose, because their characteristics are different. So, bamboo viscose actually their total structural characteristics changes. So, we should use the bamboo viscose its own model, and at the same time cover factor is not the criteria to predict the UPF. More accurate we can get by using the areal density model. So, here that is why the areal density with cotton its own model we use, and for bamboo viscose its own model we should use to predict the UPF value. So, after that the question remains, which one is better as far as the UPF is concerned. So, we studied further. What we tried, so UPF transmitters through fabrics having same cover factor and same areal density. We tried to understand, we tried to create fabric of same cover factor and same areal density, and then made from the bamboo viscose and cotton, then tried to understand the UPF value. Now, the properties which we are using here, we have selected a particular fabric of same cover factor. So, 84.4 and 84.27, and what we have got, the areal density 107 and 107. So, we have created the fabric by adjusting the ends per inch, picks per inch in the loom, and after washing we have got the cover factor we have calculated. So, these two fabrics, both cotton and bamboo, so having same cover factor and same areal density, and what we have got, that there is no significant change in UPF value. There is no significant change in UPF value. and what we have studied with wide range of wavelength. We have seen this is the transmittance percent and this was wavelength. Now, UPF value, but with wide range of wavelength we try to study the transmittance percentage. So, what we have observed that there is no distinguishable difference in the UV protection properties of cotton and bamboo viscose fibers. So, you will see that they are almost same, they are overlapping, lines are overlapping. Okay. So, that there is no difference. So, with this study what we have tried to conclude that the UPF is not affected by the that in case of bamboo viscose the common belief that the UPF is higher, bamboo viscose results higher UPF, but in our study it shows that there is no significant difference between bamboo viscose and cotton as far as the UPF characteristics is concerned. So, what we concluded here, so fabrics made of 100% bamboo viscose yarns show higher UPF than 100% cotton fabrics having same yarn count and machine setting thread density. So, this is important, it is machine set thread density, that is ends per inch, peaks per inch, which we are setting at the machine, and that is how we normally do the mistake. So, where 100% viscose bamboo viscose show higher UPF, but actually after washing or after treatment it gets shrinkage is much more in bamboo viscose. For same fabric parameters, higher UPF of bamboo viscose fabrics can be attributed to their higher aerial density and cover factor, which is resulting due to the shrinkage. So, higher aerial density is there in case of corresponding bamboo fiber as compared to cotton fabric. So, UV transmission through cotton and bamboo viscose fabric having same cover factor and same aerial density, they are almost same in wide range of waves, wavelengths. The UPF prediction model based on aerial density as input developed for cotton fabric performs equally well for bamboo viscose fiber. So, aerial density models. So, we can see, so aerial density model here we will go back. So, for cotton and bamboo viscose, although it is a little bit higher, so we can use the aerial density model we can give the input of aerial density model to predict the UPF of both bamboo viscose and cotton, not the cover factor model, and there is no significant difference in UPF value for cotton and bamboo viscose fabrics. So, that is our conclusion. So, here we can use the bamboo viscose or cotton fiber for at least for different other characteristics, not for the UPF value. UPF of both the fibers are same as per as our study report. So, we will stop here. In the next session what we will do, we will study the effect of yarn twist, modified yarn structure and fabric thickness. So, we will try to change the fabric thickness on ultraviolet protection of woven fabric. So, we will try to modify the yarn structure and yarn twist will change and also fabric thickness. So, this we will discuss in the next session. Till then, thank you.